So we've got plates that are manufactured and the diameter D is a random variable. So obviously the manufacturing process doesn't create plates of exactly the same diameter each time. And we know that the diameter is actually normally distributed. So let's write down the mean, variance and standard deviation. So in part A, we're given that 60% of the plates are less than X centimetres. We need to try and find out what X is. So another way of writing this would be to say that the probability of the diameter of a given plate being less than X is 60% or 0.6. So let's try and draw out this distribution for the diameter. Now we know that in the middle is the mean, which is 20, and we want the probability of being to the left of X to be 0.6. So we know that X has to be somewhere here, and we know that that area to the left of X is 0.6. So we're going to use inverse normal on our calculators. So distribution, normal, inverse normal, and then our tail is left because we know the total probability to the left of our unknown X value. So we're using left tail. The probability, the area to the left is 0.6. Our standard deviation is 1.5, and our mu mean is 20. So 1.5 and 20. So we get 20.380. In part B, we were asked to find the interquartile range of the dinner plate diameters, the interquartile range of D. So let's draw out our distribution and work out what the interquartile range will look like. So in the middle we've got 20, and we know that the lower quartile, Q1, is going to be 25% of the way from the left of our distribution. So the lower quartile, let's call that Q1, is such that to the left of it, the probability of being to the left of it is 25%, 0.25. And similarly, our upper quartile, Q3, the probability of being to the right of our upper quartile is 0.25. Because our upper quartile is 3/4 of the way, 75% of the way from the left. So that's equivalent to saying to the right, it's 25% probability. And if you were asked for the median or the middle quartile, this would be the median because it's 50% of the way through the distribution. So we just need to find out Q1 by using inverse normal. So we know the total probability to the left of our lower quartile is 0.25. So we're going to do inverse normal left and put our area as 0.25. Leave sigma and mu as they are because they haven't changed, and we get 18.988. So Q1 equals 18.988. And similarly for Q3, we're going to do exactly the same thing, but we know that the probability to the right of Q3 is 0.25. So we get Q3 is 21.012. Another way of working out Q3 would be to use the fact that this is symmetrical. So we know that the difference between 20 and Q1, that difference there, is the same as the difference from 20 to Q3 because it's symmetrical. Or you could have done what I did. So the interquartile range is the upper quartile subtract the lower quartile. And we get that as 2.024. So let's round that to 2 sig fig, so 2.02 to 3 sig fig.